All right. Welcome to the Energy 2306 AD project. There's a lot of things you're going to accomplish over the next several sessions. This first session I've entitled The Trial of the Century. But first, let me give you a little bit of background on where we're going eventually. Our purpose really is to provide almost universal insight as to how we are going to acquire and utilize energy in the year 2306 AD. Now, why did I pick that date? Good question. 282 years in the future. At that point in time, one of two things is going to be the case. We will have been annihilated, either through our own stupidity or through mutually assured destruction. Or we've done something halfway intelligent with the use of fossil fuels so that we could create a world that we could be self-sustaining as far as energy is concerned. And by the way, solar collectors and wind and all that stuff, all it does is create electricity. And you will see as we go forward in future sessions that electricity is but a very small part of our energy needs, and it will satisfy only a very small part of them. We have other bigger problems than that. Okay, the first session, which as I said is the trial of the century, we're going to present to you, the jury, information you have not seen before, but that has been in the public domain and that has been analyzed from people a bunch smarter and a lot more experienced than I have. I'm going to present it to you, and you can make your own decision as to whether we really have a problem with greenhouse gases. But again, I'm going to present you with the facts, and you can be the jury. All right, we're going to discuss the science of heat. Heat is nothing but the transfer of kinetic energy between molecules. That's all it is. Pretty simple. But it manifests itself in so many different ways to enhance our life that you can't even name them all. But the bottom line is we got to know what heat is in order to be able to conquer its use. We'll get there. All right, we're going to go through how we currently are using our fossil fuels, where they go, what they're used for, and really pretty important, how are we going to duplicate their complex molecular structure? We can get there. It's just that I've got to present you with the ways in which we're going to do that. Now, quite honestly, in that year, 2306 AD, we only have one reliable source of energy, and that's the sun. It fuels the solar collectors. It makes the wind. It grows trees. It grows wheat. It grows tomatoes. That's all it is. We aren't going to have anything else. So we might as well recognize that, learn to take advantage of it. Okay, part of that taking advantage is land and water. Land and water are a resource that are finite, and in order for us to take advantage of the sun, we have to utilize land and our water resources very judiciously. We have to use very good stewardship in order to balance the needs of that land and water against our needs as human beings, both from a nutritional standpoint and from an energy standpoint. Most importantly, when we get to the year 2306 AD, if you can't eat it, you can't burn it, you can't pound a nail with it, and you can't saw wood with it, it's not going to be worth very much. You can take all the gold you want to, but you won't have a market for it. Okay, let's go to the trial. We are going to pit ourselves, we, the Energy 2306 AD project, against the climate change enthusiasts. That's the trial. We're the prosecution. They are the defense. You're the jury. Okay, in reality, this all started probably back somewhere in the 70s. We don't know. And as a matter of fact, I don't know that we can really pinpoint, nor can anybody really pinpoint, where this whole climate change, Green New Deal, blah, blah, blah started. But I can tell you probably what occurred. As I said, somewhere back in the 70s. This is after we go through all of the Reconstruction, World War II, tremendous amount of energy was being used in the reindustrialization of Europe. It began to get a denser population, and the population density in Europe is quite high. Well, they were using fossil fuels. Well, they have to import all their fossil fuels, or at least a darn good percentage of them. What they were importing was pretty dirty. They were importing fuel from basically Russia, maybe even north as far as England, but not really. And some oil from Venezuela, blah, blah, blah. Now, what makes the burning of a fossil fuel dirty? Well, there's two things. One happens to be the ash content, and ash really is nothing more than heavy minerals that have been oxidized in the process of consuming the carbon and hydrogen that exists in that fossil fuel. The other thing that happens is you got sulfur compounds that are in there. Now, those sulfur compounds, they're in numerous different molecules, the most predominant of which would be like hydrogen sulfide. This is swamp gas to you. Well, the natural gas, for instance, that they're pulling in from Russia, it's got a lot of sulfur in it. Well, what happens with that sulfur, and you'll notice up here on the diagram, we create sulfur dioxide. When you consume that fossil fuel, you're going to create sulfur dioxide. Well, when it gets up into the atmosphere and it condenses inside of a water droplet, it creates H2SO4, that's sulfuric acid. That's the same acid that's in the battery in your car. That is the lead acid battery. But it's also what is the component of acid rain. You remember acid rain. Well, the Europeans have to import all their fuels. Fuels are dirty. It's mucking up the atmosphere because of all this ash in the atmosphere and the acid rain and all that crap. And on top of that, it's a horrible balance of payments. They have to create something, mostly wine, that they trade for that fossil fuel. Well, if they could keep that internally, you see, inside of their economic system, it's a whole lot better off. We theoretically, up until Biden got into his administration, we were actually keeping all of our energy monies in-house until Biden got involved. Now we've got a balance of payment problem. Well, they had it. So what they did, the solution to their problem, they knew what the solution was. The solution was to get rid of fossil fuels. They had to do that. They had to balance their payments and to get rid of all that crap in the air. However, their problem was they had to sell it to the European community. So in reality, you see, they had to create a problem. The solution they already knew, but they had to create a problem that they could sell to the European community so that they could justify the solution. So they went to the UN. And in reality, they were a solution, just trying to find a problem. Well, the UN was able to satisfy that need. And in 1988, they formed the organization called the IPCC, or the Intergovernmental Panel on Climate Change. So you can imagine now, this is a group of climatologists, because where was their problem? Where was Europe's problem? It was in the atmosphere. So where would you go? Well, where I would go is different than where they went. They went to climatologists. Now, a climatologist looks at everything through the lens of weather. Well, they know, you know, and I know that the heat from the sun creates the weather. So, part of the products of combustion of fossil fuels was CO2. CO2 is a known gas to be able to absorb radiant energy. It also emits radiant energy. As a matter of fact, they're equal. It absorbs it, but then it really just immediately re-emits that energy. Well, it can be viewed as a greenhouse gas. And what that translates into is that it's kind of a blanket. It's visualized by everybody as kind of a blanket. Well, in reality, yeah, that could be the case, but I'm going to lead you through the, quote, trial of the century. I'm going to lead you through the proof that it ain't a blanket. As a matter of fact, it probably does more harm than good to get energy onto the earth. But we'll get there. You'll see why we get there. Okay.